Hi, I'm Cheryl Leach. In this problem, we're asked to find the area of the region bounded by the curve x plus the sine of x, on the right by our vertical line at pi, x equals pi, on the left at 0, and at the bottom by our x-axis. So I'm looking for the area of that region. Now I know that I can use integration to find the area of a region. So I know in this case that the area is going to equal the integral from a to b of f of x dx. Because my function is non-negative, that is, it's all above the x-axis. So let's fill in the information for this particular problem. The limits of integration, I'm going to be going from 0 to pi, and the function is going to be x plus the sine of x. Okay, so I have my definite integral. Basic rules will apply for this one. The integral of x dx is x squared divided by 2. And the integral of the sine is minus cosine. So I've got minus cosine of x. And then I'm going to evaluate all of that from 0 to pi. All right, so we need to plug in our upper limit and then subtract what happens when we plug in our lower limit. So plugging in the pi, I'll have pi squared divided by 2 minus the cosine of pi. Then I need to subtract what happens when I plug in 0. When I plug in 0, I'm going to have 0 squared divided by 2, which is just 0, minus the cosine of 0. Okay, so pi squared divided by 2, I'm just going to rewrite that. What's the cosine of pi? Well, the cosine of pi, that's one of my special angles, and the cosine of pi is -1. So I'll have minus a -1. I'll be subtracting 0 and then adding the cosine of 0. Well, what's the cosine of 0? Again, that's one of your special angles. The cosine of 0 is 1. So I'm left with pi squared divided by 2 minus a -1, that's +1 plus 1, or pi squared divided by 2 plus 2. And that represents the area of my region. Now remember, we are talking area, so I'm going to put in square units. I hope that was helpful. Thanks.